Ready to get started? So this week we got the grad panel, so I'm just going to go ahead and let it take it away.
Okay. Let's start off by introducing ourselves. I'm Dan Knopf. I'm the graduate advisor here. This means I'm a mathematician, and I am involved in recruiting our graduate students and in advising them as they go through the program.
I'm Jeff Fowler, and I'm probably here because I've had lots of graduate students that work with me over the years.
I'm Robin Newmare. I'm a first-year graduate student. I just came from the University of South Carolina last year.
I'm Peter Müller. I'm the statistician on the faculty now in math. We hope to recruit more, but I hope to tell you a little bit about statistics programs.
I'm Cornelia. I'm a first year. I came from Wellesley.
I'm Michael. I am also a first-year PhD student here, and I came from University of Chicago.
So, I don't know what might be an effective format. Should I say a few words or just see if they've got some questions?
Tell them how to apply to graduate.
Tell them how to apply to graduate school. I get a large quantity of unmarked bills. No. All right. The process is generally not, in some way, some aspects of the process are similar to applying to an undergraduate institution, though it is more expensive. You are making an investment in your future of considerable importance. So what you want to do is you want to apply to a range of schools, bracket them. Some try to have a good idea of what your competitive abilities are. So some dream schools that you hope to get into but may not have a super good chance. Some schools where you have you believe you're a good fit and have a solid match, and then a couple of safety schools. It makes sense to do some research on their websites. If you're interested in doing, say, logic, and you apply to the University of Texas, we have a problem because we don't have anyone who does research in logic, and we're probably not going to admit you because you wouldn't be happy here. So if you don't know what you want to do, that isn't a disadvantage necessarily, but if you do know what you want to do, make sure that there's some faculty there who are interested in it. People often ask me which parts of the application are most important. That's going to, I think, vary from institution to institution. We try to look at applications holistically. To be honest, the general GRE test doesn't mean all that much. The GRE subject test means something here. At some of the institutions, it means a lot. One can argue about how much that should mean. We look at breadth of coursework. We look at your grades in the courses. We look at letters of recommendation. Here, I think they matter a lot. We look at graduate experience. I mean, the best predictor of success in graduate coursework is previous success in graduate coursework. Having said that, we have about 400 applicants every year, and our incoming class generally is not larger than 20. And this is because we offer financial support to essentially everyone we admit, unless they've got outside support in some cases. And that's true of most math programs. There are a few math programs that will admit you without support, but by and large, most of them will admit you with support. That means that if they only have this much support and there are this many qualified students who apply, they do their best to choose, but there probably are more qualified students applying than we can support, which is why you shouldn't put all your eggs in one basket. Follow directions. If you Gauss 2.0, I will still admit you even though you notched the application. But unless you're Gauss 2.0, it helps to behave like an adult. Follow the directions on the website for whatever the application process is. This should be pretty obvious. And in your statement of purpose, I don't know what, this may be very subjective so for the committee, but
Yeah.
you know, tell us something about your personal experience, why you're interested in going to graduate school. It shouldn't sound like flowery platitudes. One day the heavens opened and I realized that math was the most beautiful intellectual activity that the human mind can hope to aspire to. Unless that is the way you really feel, in which case we should talk. But if you believe there are any weaknesses in your application, you can address them in the statement of purpose. Yes, my GRE subject score is a little low. I have test anxiety. I was sick that day. Or I do better in non-timed test situations. Most of your life as a mathematician, if this is where life leads you, you won't be doing timed tests. I don't have co-authors standing over me with a stopwatch usually. And you can address those issues. The people that you ask for letters, it's usually better to have someone who knew you in an upper division class and is familiar with your work, rather than someone who's famous, but maybe you were one of 100 students in her or his freshman calculus class. And like, yes, I saw him, he was in the back. You know, they should be able to write something substantive about their experience with you. And I've talked too much, and that's everything I can think of offhand.
I agree with everything Dan says. Maybe I add a couple of observations. And to some extent, you know, anything I have to say is just my personal view of how graduate students should be selected and so forth, and other faculty members who are involved in that decision. They may have their own parameters to work with. I put quite a lot of weight on letters of recommendation if I'm involved in any kind of selection process. Especially letters that come from mathematicians who I know are actively doing research and are themselves actively working with and supervising graduate students. So you people are fortunate to be at a university with plenty of the above. There are many faculty members in our department who actively do research, of course, and who have lots of experience training graduate students and working with graduate students. So those are probably the faculty members that I think would be best for you to ask to write a letter of recommendation from. I think that the business of going and finding a faculty member who you know because maybe you had an undergraduate, presumably, class with them, or in a few cases maybe you sat in on a graduate course that they took. That's an important first step. You can talk with any of us about the process of applying and going to graduate school. But you know, if you get to know a faculty member well enough because you took their class and you feel that you did reasonably well and you want them to write a letter of recommendation from you, knock on their door or send them an email or find them and talk to them maybe a little bit about the schools that you intend to apply to. Talk with them about your own mathematical interests. That's a good conversation to have because it helps them write a letter about you. Obviously, they can write a letter about you based on how you did in their course, but if they've actually got you sitting in front of them for 15 or 20 minutes and find out something about you, that kind of helps them write the letter. And to my way of thinking, at least, the most reliable letters of recommendation come from faculty members at universities who themselves are experienced in training graduate students. There are many good small colleges in the United States, and we certainly take students from good small colleges, but sometimes it happens that if you are a student at a small college and you enjoy being in classes with just 15 or 20 students, which is certainly a plus, There's a little bit of a downside to that, and that is that the faculty members of those small colleges maybe aren't themselves so involved in research, or maybe they never had the experience of training PhD students. So those letters maybe aren't quite as strongly received by us. They're okay, that counts and so forth. But as I say, the best letters I think come from people who have experience training graduate students. One other remark I would make, I kind of think, and this is just a very rough description really, I think it's probably a good idea to apply to at least 4 or 5 graduate programs. You know, just because, let's face it, there's a certain amount of luck in the process. You know, you're going to find, if you look on the other side, that there's some faculty members who sit in their office or get together somehow and they have all these applicants in front of them and they're all pretty good and they have to choose some. And, you know, you can sort of say, well, gosh, here's an applicant from Florida. We haven't had anybody from Florida for a while. Let's choose that person. You know, well, you know, if they're all kind of equally attractive, you got to have some explanation for why you made your choice.
A legal explanation would be
good. Yeah, you know, there are people who are really obviously strong candidates. Okay, they'll get an offer. And then there are people who clearly aren't really ready for graduate school, and they're probably not going to get an offer. And then there's the kind of the vast bulk in the middle. You can distinguish from various things, GRE scores, grades, you know, you can try, but it's kind of a rough process, and oftentimes you do come down to situations where you're not quite sure which one you should choose. And that's where there's inevitably a little bit of luck in the system. So in view of that fact, I would say apply to at least 4 or 5 places. You know, if you applied to 9 or 10, I wouldn't think that was crazy. 20 is probably crazy. But I would say at least 5, and I wouldn't think you'd need to apply to more than 10 if you're, you know, if you have some mathematical talent and interest in the subject. My final remark is that graduate school in mathematics is not for everyone. It's something to do when you are pretty confident that you have an interval of several years in your life where you can really devote a high proportion of your time and attention and energy to mathematical work. If you like to do other things, you know, go mountain climbing and so forth, I don't know, it probably wouldn't be too compatible with being a graduate student in mathematics. It does take a lot of time. It's not just a 9 to 5 thing. Yeah, the best graduate students find themselves trying to figure out a proof of a key lemma at 2 o'clock in the morning. Yeah, and you have to have a lot of dedication and determination to do that.
If you like it, that's great. If you don't like it, it's not great.
Yeah, so it's different than being an undergraduate. You know, when you're an undergraduate, you do a lot of homework problems. Those are mathematical problems where somebody already knows how to do them, and they just fit perfectly. You know, you apply this theorem and that theorem, and everything works out just right. When you're doing research, it isn't that way at all. You know, the process of discovery is messy, unclean, complicated, and you usually don't get it right the first time or the second time. Columbus is a good example. He tried to find a route west to Asia, and he failed miserably. Keep that in mind. He made an interesting discovery, obviously, but he had no idea what, you know, how it was going to work. And sometimes mathematical research is like that. You think it's going to go one way, but then when you really understand it, you realize it's different than you had anticipated. And it may take a while before things are worked out so they're really kind of in good shape, so to speak. Publishable maybe is the right word. Anyway.
All right. I had 2 main things that I wanted to say. First of all, well, this sort of goes with what you were saying, that at some point it comes down to sort of a crapshoot of who's going to get in. If you're a qualified candidate but not probably the best person in the pool, So I knew I wanted to come here for a while, and I met with Dan the summer after my junior year. So right going into my final year of college, I came here and just met with Dan and said, hey, I want to come here. Mostly, to ask questions about the department, but mostly so that he would know who I was, and hopefully I made a good impression. And then I got put on the wait list, and I still wanted to come here. And so, one of my rec writers who knew people here sent emails. I was like, hey, she's good, let her in. But so I got in, and it's good, and I fit in well here. And it's kind of like, this application process is not a time to be prideful and be I didn't beg to get in, but I made my intentions clear. And I think it's a good thing. I wasn't begging at MIT. I'm here at somewhere that it was realistic for me to be here. So yeah, if you have somewhere that you want to go, I think, yeah, don't be too proud to try to make it happen with all your resources. And the other thing that I wanted to say, do you guys know what the NSF fellowship is? Yeah, apply for it. For two reasons. First of all, so you apply, it's due in a month. So if you guys this is your year, start working on it now. But it gets your application for the schools you're applying to pretty much done. Because you have to write a personal statement. You also have to write a research proposal, which was something I had not done before. So it's a really good experience, just the application process. And your personal statement's done, your rec letter's already requested, so it makes the rest of the process very streamlined. And also, getting one is great, because then you don't have to teach, and it gives you, not teaching so far has given me a lot of extra time to do math, which is nice. It's a very valuable thing. I would definitely apply for it. I think that's a good piece of advice. Just apply for it.
There's not that much to add. Maybe one thing to add to your recommendation for going out for these scholarships. It's not only the time that it gives you, it's like you stick out in a crowd of many other applications. That's something we definitely look at, yeah? I would immediately notice that. What came up before, the issue of selecting the people you ask for letters, it's a very delicate issue, because on one hand, you really want people who are known. Yeah? The first thing I look at when I see applications is, do I recognize any of the letter writers? If I do, it's almost a done deal, yeah? Or I know how to calibrate the person. On the other hand, there's no point if the letter then only says, yeah, he was in my class or she was in my class, yeah? So
I've seen him in the hall.
Sorry. At least he or she hangs out in the department, yeah? So it's a difficult decision problem, yeah? Try to do your best about it. I definitely would also like to echo the advice, really only do it if that's really what you want to do, math grad school, or I would love to argue there's variations of it. There's programs in statistics or biostatistics. It's really only for you if that's really what you want to do, just as a way of passing time and getting on in life. It's really a bad choice, yeah. That said, it can be a lot of fun, and if you enjoy these kinds of things, I think it's a rewarding career. Perhaps things are easier than what it might seem at this moment to you. So we say there's a journal for every paper, yeah. There's a grad school. There's a program for every student, yeah. And part of that has to do with programs are specialized. Definitely when you write your application, go online and check them out. Maybe mathematics is a bit different from, I'm in statistics, so many schools have a separate statistics department, which tends to be much smaller, and they're specialized. So if I see an application to a program where I know we specialize in one particular area, and that's an application of someone who talks about something entirely different, that's lost effort, yeah. I can also only emphasize any flowery, exaggerated justifications of why you want to go into grad school, or anything that's perceived as just following a template. It really doesn't get you anywhere. On the other hand, if there's really a good reason why you want to study statistics or this particular area of math or so, by all means state it, yeah. Don't try to appear more expert in what you are. I mean, people see through it, state things that you understand. Look not only, like, so if you're interested in mathematical work, I mean, there's variations. For example, statistics. Somehow statistics programs are less known, like we don't tend to get as many applicants as in mathematics. It's a bit more specialized. You can do research very similar to what you could do in mathematics. It obviously requires a different set of skills and interests, but so keep your eyes open, like don't be too narrow-minded. Yeah, you can do very mathematical work also in, I don't know, operations research, engineering, statistics, everything. Depends a bit on where your interests lie. In terms of, so I assume by now you must have planned your coursework for this year, but so what we really look at, so what I would look at in applications, not so much that somebody did like the most advanced possible courses in graduate level statistics work, but I look for the basics, yeah, like did the applicant do well in linear algebra, real analysis. I love it if I see he or she did a bit more probability than the required undergraduate probability, so strong foundations is what I would love to see. When we look at graduate student applications, in a way, like if we admit graduate students, they become kind of our junior research colleagues. Like I want people who will then eventually write papers with me, and those are the successful candidates.
All right. I'm not really sure what specific to say. One thing I will say is that Wellesley is a very small school, so I'm offering the liberal arts student perspective, which is something you guys may not be quite connected to. I'm also offering, it's an all-women's college, so that's good to know too. So my recommender choosing process was something like I chose professors who had seen me a lot and who had seen me in office hours, so struggling through problems, seeing the way my mind works and seeing the fact that it can work well. And I did happen to choose people who actually were, even though they're working at a small school, they were active researchers, writing papers, going to conferences. So all of that stuff was still happening. For my
Clearly
state.
made good choices.
Apparently it worked. And then for my statement, I think, like in case you're wondering sort of what to write about, I wrote a lot about experiences where I had done research, of course, and where I had experiences in math that were really fun. So like where I had worked with people on homework, where I had, like I went abroad to Budapest and I did math there, and that was really exciting. And so just any experience where math is fun and where you learned a lot and where you wanted to learn more, I think those are all good things.
So I think I'll add a comment to the discussion on the personal statement. So at University of Chicago, I was among peers who were very, very, very smart. They had, some of them had published papers already, some of them knew what the frontiers of mathematics were like, and they could speak that language, and they included that in their statements of purpose. I wasn't at that level yet. I didn't have any original research on my record. So what I aimed to do was to demonstrate a certain level of mathematical maturity on my personal statement by describing my RU experiences. I did RUs over the summers, summarized a little bit about my research and why that got me interested in math and graduate studies. Regarding recommenders, for those of you who are not seniors or in the application process now, it's a good idea, as Cornelia mentioned, to go to office hours and to work through problems with your professors so they know how you work through mathematical problems. I don't know if this is recommended by the faculty members on the panel, but I had two senior faculty members for two of my recommendations, and then one of my recommendations was actually from who at the time was a postdoc at the University of Chicago, whom I worked with on my RU paper. The reason I chose him was because he knew me really well. He knew my research capability, even though he's not, being a young guy, he wasn't as well known as senior faculty members.
I would
sounds like an excellent way to put it.
Yeah, I just want to agree with a couple of things that you have, three of you have said. I definitely agree with that a more junior person who knows you better may well be able to write a more compelling letter than a very senior person who doesn't know you. Going to office hours is important at an institution of this size. We do get to know, I get to know my students much better when they come to office hours than even if they're doing well, if they're just somewhere in the course. And that doesn't mean we have favorites, that doesn't mean we assess or grade them differently, it just means I can say more about you because I know you better. At a small institution, all of your faculty will know you, let's hope. But at an institution of this size, you have to be somewhat proactive about making sure that your faculty know you. You have to expend a little bit more effort, perhaps, to get the kind of experience that you get automatically at a small place. That's the flip side of being at a big place. Is you have to work a little bit at making sure that you are coming to office hours and getting the full range of educational experiences. The other thing, to echo something Peter said, is it's not just about choosing between algebra and topology and geometry, or maybe algebraic topology or algebraic geometry, or there are very applied areas in which there's actually much more of a growth in the job market than in traditional mathematics. You may decide that you have wanted to be a researcher. You may decide that you primarily get joy out of teaching, and that can affect your choice of graduate program too. Now we have students who, from here, I would say most want to go on to research-oriented institutions, but a fair number find out that they're extraordinarily good teachers and they want to go on to good institutions that value instruction. And I don't see one as above the other. I see us side by side. We do some things well, but we do some things better. They do some things better. But if you have insights now into what you like, that can inform your decision about what programs to apply to.
Yeah, I will add one other thing I thought of. So of course, when you apply and go to graduate school, I suppose the goal is to do significant research and to move on in your career in the world of mathematics. But I would also say that, my way of thinking at least, your experience being a teaching assistant and teaching is very, very important. Eventually you start to be judged a lot on that. And learning how to teach and explain mathematics clearly and concisely to other people who don't know it as well as you is a really important skill worth developing. For example, if you, say, have a career in industry, oftentimes you're selected, you're hired because of your skill in explaining mathematics to other people who need it, who use it, but they're not themselves mathematicians. And that's kind of a form of teaching. So if you get good teaching evaluations, if you're a successful teacher, that actually helps your career in many ways that maybe don't seem quite so obvious at first. But it's a very important part of it. Something you start to do as a graduate student usually. Maybe we should ask if anybody has any questions for us. Yeah.
If we are not happy as an undergrad, is graduate school for us?
It depends. Short answer, it depends. Longer answer, it depends on why someone would be unhappy. If you find your current courses boring and you are eager for more challenges, or you find you only enjoy your math classes and you really do not enjoy the required class in undergraduate, in underwater basket weaving, then the answer might be yes, you might be very happy in graduate school. If you feel like spending a long period of time thinking about a difficult problem is a chore rather than rewarding, then maybe not. It's not as hard as anyone in their first semester of graduate school will think. Honestly, it gets better. But I love what I do, but it is very hard. And I do it because I couldn't see myself being this happy doing anything else. But if you can see yourself happy doing something else, then that might be a conversation to come to graduate advisor office hours and talk more about in person. It's like, when I used, in my misspent youth, I tried to be a bike racer. I wasn't very good. The best I ever did was finish in the middle of the pack. And I didn't take drugs, so But the point is, I enjoyed the hills the most, even though it was the hardest part, because I was slightly better on the hills than other people. So even though it was really hard, it was rewarding. And if you can say something like that about your experiences in math, the answer is probably yes, you'll be happier. If you don't have that feeling, that's fine. It may just mean this isn't for you.
Anybody else have any questions? Yes?
So I guess a big question a lot of undergrads might have is, how did you convince yourselves that graduate school was right for you?
That's a good question. Maybe one thing to do is like hang out at colloquia, at seminars, and there you can ask like faculty like what they would recommend is sensible to go to. This any given day there's I don't know how many seminars around campus. If you kind of enjoy that stuff, then chances are it's good for you. If you get really bored.
I think, everybody fits into the world of mathematics in their own individual way. So you might have good reasons for going to graduate school which wouldn't be good for another person. I could extrapolate maybe a little bit on your question and observe in a more negative way, I guess. Sometimes people come to graduate school at the University of Texas and they don't make it. They drop out after a while, or they just don't do very well. It's not a perfect process of selection, for example. And yet, I kind of think that over the years that I've been here, the people who I've seen who are graduate students and just don't do very well and drop out of the system, I don't think it happens very often because they're not smart enough or even because they're not dedicated enough to mathematical work. I think the primary, or one of the primary reasons it happens is because something else is going on in their life that has nothing to do with mathematics, and it takes them away from their mathematical work. I'm 35 years or so that I've been here. Occasionally I've known graduate students who came to school and got divorced, for example. Well, that's a big thing in their life to deal with. It has nothing whatsoever to do with mathematics, but it's a huge distraction. And oftentimes it's such a distraction that they just don't have time for their mathematical work. Illness or a desire to get involved in other things could be that way. It's a time to really focus your attention on one thing.
And occasionally people are successful and they find they just don't enjoy it. But
yeah, that can happen.
I think what might be useful, and I don't want to put the three of you on the spot, I'll let you rock now. What might be useful is imagine yourself writing this letter of the statement of purpose in the way that I said, telling a story of what made you think that graduate school in math, what makes you think that graduate school in math might be right for you. And some of you, the three of them have made this decision. Maybe they can share with us some of the factors that went into that decision. But do the exercise of writing the statement of purpose. Can you convince yourself, after reading it, that you really want to be a mathematician? And if you can't, then that's maybe something to think about. Is there a compelling story for why a mathematician or statistician or biomathematician or whatever interests you? Do you have a compelling story? Even one that convinces yourself of where that interest comes from. And all of you told us in one way or another what made you think about coming to graduate school?
I mean, I can say I was inspired a lot by my professors. Like, at the moment, I would like I envision myself eventually in a job where I do a lot of teaching, and I teach, you know, like all kinds of things. I teach them calculus, I teach them higher level courses, you know, things where I can cater to people who don't know how cool math can be, or people who like math and like want to learn more. I want to teach a lot, and then I want to do some research. And so my experience with teaching came from like just tutoring help room at my school, or watching my professors teach and seeing them inspire me, them inspire my friends. And then my experience with research, I mean, I think that a lot of that comes from like if you have chances to do RUs or anything that involves some kind of investigation in math that's sort of unknown. Like, that gives you a good experience of what it's like to do research and whether that's something you could enjoy. Of course, you have to take your RU sort of like, you have to think, well, I liked it, but not a whole lot. That might just be, was the problem the right fit for you? So, you know, if the RU wasn't perfect, that doesn't mean you don't like research. It just might, you have to consider things carefully. But all of your experiences together sort of make good suggestions.
Yeah, I don't have too much more to say. Research, I mean, for me, it was my first RU. I loved it, and it was wonderful, and it's what I wanted to do forever. But I don't know if you've gotten to do research or not. But Cornelia, that was a good point, that not all RU experiences are the best. But something to consider is, yeah, you'll get paid more if you go get like a real job, like go, you know, work in a bank or do whatever. And also, like, you don't get weekends off. I mean, maybe eventually. I work on weekends, I work at night, I work in the morning, I work really early in the morning. Like, you do math all the time, but it's like, I think it's really fun. But it is something that like my other friends that I graduated undergrad with they're working at banks, and they're making really good salaries, and they're living these glamorous lifestyles in cities with weekends off. And it's not that, but it's like, I think it's just definitely something worth considering. Just factor that in and make sure that it's worth it to you to forgo those things. But it's really fun.
And a lot of enjoying grad school is finding the program that fits you also. Some of it's like, what do the professors do, and some of it's just the fit of the students. Like, if you go to, at some point you should start visiting schools, especially once you've been accepted, and then you find a community that seems to really support you well, or challenge you if that's what you're looking for, and that's also really important.
You will usually get you will often get an opportunity to visit if you've been accepted, but it doesn't hurt to visit if you're really interested in an institution even before you've been accepted. It doesn't hurt.
I guess this might sound like a kind of flowery story, but my freshman year in college, I took an IBL calculus class, and at first I wanted to deal into physics, but then I realized after taking this class that this is the type of challenge that I want to devote myself to. And I'm sure all of you have experienced that since you're all here by now. IBL, well, it's I think
Inquiry-based learning.
Inquiry-based learning, modified more method type class. It's where the students do essentially all the work. Well, I mean, students always do all the work, right? But
Faculty, we just sit in the back and eat our lunch.
Right. Yeah, that's exactly. So basically, there's students are given a script of definitions, theorems, without proofs, and they have to conduct the class. They have to prepare the theorems and conduct the class. Anyway, so later on in my undergraduate career, I was able to work with a professor on editing the book, and in that process, I sort of got to see, actually witness him working with other mathematicians, which inspired me. And I also was able to have a reading course with a professor, and I guess I got a sense of what it would be like being a graduate student and working with your advisor. I really enjoyed that.
Let me add to that. There's one important way, which hopefully the three of you are still realizing, that, and this speaks to questions about am I going to like this. There are some ways in which graduate school is qualitatively very different from an undergraduate experience. It's difficult to quantify, but maybe until you experience it. universities have their roots somewhere in the medieval guild system. And as graduate students, you're more apprentices than you are students. Either Jeff or Peter said this, and I don't remember who, and I apologize, but that, you know, you are here to work alongside us and learn the tools of our trade, which happens to be mathematics, and someday become our peers and our colleagues and write papers with us. And that's different from being in a class and getting a grade. Yes, there's some required classes at the beginning. Yes, you have to get some grades at the beginning. But ultimately, it's about forging a very different learning experience, which is much more one-on-one. So if you don't like your classes, but you do like one-on-one interactions, you know, these are all things to consider. But it's a distinctly different culture. It's hard to put that in words well.
Yeah, somewhat related to that, I would add sort of a far into the future comment here. I guess 25, 30 years ago, you went to graduate school in mathematics, and your goal was to write your dissertation. And then oftentimes you went off to another job, maybe a postdoctoral position, and you took parts of your dissertation and wrote those up as papers and submitted them to journals. I would say those days are largely over. The dissertation has faded in importance. Instead, what I would say today is that while you're a graduate student, maybe you're in school for 4 years or 5 years, think in terms of working out your research, solving problems, getting involved in research projects with your advisor or by yourself, and the product you're going to produce is a manuscript that will be submitted to a journal. Oh yes, and then some point along the way you want to write part of that up and call it your dissertation, because you do want the university to give you a PhD. It's sort of awkward to go through a career in mathematics without that. Not impossible. Not impossible. There are some exceptions, but that's usually the right way to do it.
Do need to be close to Gauss 2.0 for that sort of work.
Now, you can see this change by just observing the behavior of this department at the University of Texas. Maybe 25 years ago, when we hired postdoctoral people, generally they had a dissertation, and that was it. Today, the postdocs that we hire here, if you go to their webpage, you can see that while they were graduate students, they probably maybe had one paper published and maybe a second paper was submitted for publication. Okay, those are the people we hire here. Those are also the same people that get hired at Michigan or UCLA or other sort of similar large universities. We don't really see the dissertation, or rarely see the dissertation, of people that we hire. So when you're in graduate school, you're working toward the day in which you apply for your next job after graduate school. And the most influential thing you'll have in that process are letters of recommendation from mathematicians that you've gotten to know as a graduate student, and the papers that you have written or partially written or that are in preparation, hopefully one or two of them maybe submitted for publication already, because those are the things that the future employer is going to have access to. They probably won't ever see your dissertation. So that's kind of faded in importance. Time passes, things change. Anybody have any more questions? I think there was a question over here, I thought. You had a question?
Are you, you're the graduate advisor, are you accessible to, are you available?
I have graduate advisor office hours on the 8th floor in 8.146, which is in the main math department suite of offices, Wednesday afternoons from 3 to 5. In fact, I came here directly from there. And frequently, people who are undergraduates here but are thinking about going to graduate school will come in and talk to me and ask more specific personal questions than we can address here. Like, here's my list of schools. Do you think that I'm aiming too high? I'll look at it and try to give you an honest answer. Excellent. Just to follow up on one thing Jeff said, this is related. Another way in which graduate school is different, the question of will I enjoy it, will I be happy? Though there is coursework is important, and in the first year or two, coursework is often stressful, we're sorry. The process of creating new knowledge is, don't make the mistake of looking at graduate school and say, oh, here are some enormous list of courses that I need to take and pass, and that is the bulk of getting a PhD. That isn't. That is laying the groundwork for you then to work pretty much one-on-one with someone and develop specialized knowledge in an area. You know, the explosion of human knowledge is such that to do anything at the forefront of research, we have to become very specialized. I work on the left kneecap. I'm sorry, the right kneecap, you need to see her down the hall. You know, we're very specialized. And the coursework will get you a broad grounding in mathematics, and then after that, the process of becoming an expert begins. So if that kind of intense learning sounds appealing, great. If you don't enjoy classroom situations as much, their importance will fade. After a certain point in graduate school, not yet, but your grades won't actually matter. Nobody looks at grades when they're hiring. They look at the quality of your research that you've produced. So grades will matter in terms of getting into graduate programs, and they will matter for a while afterwards, but at the end of the day, what will matter will be what you can discover.
Don't take it too serious. It's not the final decision. Yeah.
Right.
If you apply for math grad school and you go somewhere and you find out it's not what you wanted, it's not uncommon if you have a good reason that you discover your interest lies elsewhere. The students change field. It's not the worst thing to happen.
No, it can be a very successful outcome. Our retention rate is really quite good. But when people leave, it's seldom because they weren't successful. It can be, well, in some cases, I want to be closer to my girlfriend, I want to be closer to my boyfriend, personal reasons like Jeff alluded to. In other cases, they find, I'm good at research, I just don't enjoy it that much. And that's okay too. You still, if you leave someplace with a master's in mathematics, you'll be very employable. A master's in mathematics correlates quite nicely with an income bump. So something we've left out, because UT is so focused, I think, on PhD, is that a master's only takes 2 years, and it really can pay for itself economically. A doctorate takes 4 to 6 years, and it pays for itself in quality of life, but maybe not in the same way in terms of foregone income versus an immediate bump in the money that you're making. So Robin alluded to that in her answer, that PhD is its own thing, but if you're really good at math, consider getting a master's somewhere, not here. But because we don't really have a program. But it can be a great way to, for an investment of only 2 years, make a substantial difference in your income.
Do you solely accept people, for the most part, who have original research or REU experience?
No, I would not make that kind of a blanket statement. We really try to look at things holistically. If you are at a smaller institution, like Cornelia was, then an REU or Budapest or something like that can be very important. If you are at an institution like this, it may be less important, but we look at things holistically. I also want to point out that the right word there is we. By the time you're admitted in this program, at least 5 people have looked intensely at your file. It's not a decision any one individual makes. It's made by a committee. And although other schools have somewhat different systems, that will be true everywhere. So there are a lot of eyes looking at it. And so, you know, maybe person X thinks that REUs are super important, and person Y only looks at GRE subject scores, but person Z says, wait a minute, I know this person's advisor. She's really strong. She's not going to sell me a bill of goods. I have some confidence in this student. So, you know, there's always multiple viewpoints, which we try to use to come to the best decision possible.
You know, one thing you might consider, if you are an undergraduate at the University of Texas, during your maybe junior or more likely senior year, try to take some graduate courses. Sit in on graduate courses, or maybe take them for a grade. Most faculty members will grade you on an individual basis. They won't necessarily, you know, cause you to compete with the graduate students who are taking the class. That's a very, very good experience to have. And I would even go further and say, for example, if you decide to sit in on the graduate real analysis class and you do well in it, then when you go to graduate school, take the graduate real analysis class again. It'll be offered by somebody else who has a different way of looking at things, different point of view. And since your first year of graduate school is oftentimes the most difficult, it'll give you a sort of confidence-building experience, because you'll be taking a course where you've seen a certain amount of it before. And there's nothing wrong with that. Yeah, because you're going to meet a new faculty member and see it in maybe a different point of view.
I want to add something to what Jeff just said. So I came from ASU, and years ago when the dinosaurs still walked the earth, and I didn't have any research, any REU experience, but I did take quite a few graduate classes, and I think that probably helped me in the application process a lot. And also, byproduct of taking a lot of graduate classes, especially, I mean, ASU pure math is not like huge there, so like at least 3 of the graduate classes I took were all from the same person who happens to have once been a postdoc here at UT, and she wrote me a letter. And I think, in fact, I think 2 out of the 3 letters I had were written by people who I had taken graduate classes with. So I think that was probably beneficial. Just another advantage of doing something like that.
Yeah, and it's a way of finding out, do I like this stuff, if you don't love it already.
Anybody else have any questions?
If you had any advice to give to yourself as a freshman, what would it be? Like,
As a freshman in undergrad?
yeah.
You mean a first-year graduate student?
No, I'm sorry, undergrad, like a freshman undergrad, yeah.
Oh.
Mathematically?
I'm gonna let one of the 3 of you answer that, because I can't remember that.
I'm having a hard time.
What I do know is that I started out really fast. Like, first year I took, you know, a couple courses that were above calculus and were good because they offered some proof learning. Like, I learned how to write an okay proof. And then my second year I took algebra and analysis, and I learned how to write a very good proof, or at least according to my instructors. And so that really set me up to try new things and take more exciting classes during my junior and senior years, and have the chance to actually be competitive for getting into an REU or any program that I wanted to get into. So just starting fast and meeting other people in the mathematics communities. So if you take real analysis, find a study buddy, and then go to office hours and do all these things that really immerse you in math, and that really, you'll have fun and you'll learn lots and you'll want to learn more maybe. And
I would strongly agree with the notion of working together and
study buddies are great. It's all about a study group.
Because a lot of, so maybe statistics is a bit different there, but a lot of our research proceeds collaboratively. And if you're not good at that, you're at a handicap.
Right. Well, that's a great point. And it's one that I make I want to emphasize, agree with Peter emphasizing Cornelia's point that, unless the instructor in the class has specifically said, okay, this is a take-home exam, and you have the honor system, and you have to work alone, most mathematics these days is done collaboratively. I collaborate sometimes even when I could write the paper by myself, simply because I like working with my friends. It's generally much more enjoyable to study, even in graduate school, to study in groups and not be knocking away at something by yourself. If you enjoy doing it yourself, that's fine. But mathematics is often more enjoyable and often more productive when it's done with one or two buddies. And I would encourage to start thinking in that way sooner rather than later. Don't wait till you're in graduate school.
Of course, I mean, you should, of course, work on all the problems by yourself and hope to do some of them by yourself. You don't want to be completely dependent, but don't be afraid to work with people.
Two specific things. So Cornelia and I met in Budapest, and they have this study abroad program. It's a math program, and it's very cool. It's because there are two study abroad math programs. There's one in Moscow too, but most of the time, so I don't know. It was neat to have a study abroad experience that was not sort of this blow-off semester that a lot of other study abroad programs were in. Really, really hard classes, like very challenging semester.
But they didn't have to be hard.
No,
like
you're right.
You could take classes to match your skill set, which is great.
But it was cool. That for me was the first time I'd ever been really sort of immersed in this environment of a bunch of all my friends liked to do math, like doing math with people a lot. Because at my undergrad institution, I don't know, I just didn't have that same sort of community. But that was super cool experience. Also, REUs are great. Like definitely. And yeah, it's cool that you're also a freshman and already thinking about things in the future. That's impressive. But yeah, just do REUs. Apply for REUs.
Research experiences for undergraduates.
Oh, yeah, sorry. It's okay.
I belong to the AAAA, Association of Americans Allied Against Acronyms.
For someone who doesn't have quite a strong, like I can graduate in the spring, but I don't have as strong of a background in mathematics. But I'm planning on applying the next year. What could I be?
My sister, this is kind of random, my sister is a psychology graduate student. She's actually human behavior development, and she did 4 years, had sort of a weaker background, and she decided to take an extra year. So I don't know if you should necessarily take an extra year, but she took more classes, got more experience, got really good grades, and that, I think, made it possible for her to get into graduate school when she wanted to. So something involving taking courses is always a good idea, and working with people. Does that help? So she's in graduate school right now, at a good program.
Yeah.
Granted, in a different field.
In general, leaving with a stronger background in mathematics or mathematics or statistics, is better than leaving fast. Math is not an area in which you can get into a competitive graduate program with a major in a different area. It just doesn't happen. The content knowledge that you need to start a graduate program, the content is huge, and you can't catch up. There are other areas in which it may even be advantageous to have a major here and then do graduate work in another area, and that doesn't work for math. So come talk to me downstairs. Not now, but
What do you say that a master's degree might be better for someone who is interested in teaching rather than doing full-time research for an extended period of time?
Maybe. But I think, for example, if you want to teach at university level, you probably do need to have a PhD. Many universities kind of restrict the faculty that they hire to people with PhDs.
So the master's, you'll be able to compete at community colleges, and that can be a very rewarding experience. But you are limiting your employment opportunities to those.
Something that, this might be like not good advice, you guys might not like this, but what I would suggest is if you're thinking about going to graduate school, apply for the PhD program because you'll get funding, and then if you want to leave with a master's, you can. And I think that kind of thing is so true. It's frowned upon, I think, but it's true.
That's just simply the way it is.
No, I mean, people change often, but I mean, I would like to add to that. Many programs have often you have a situation that there's clearly two different trajectories for masters. There's like the exit ramp masters, and there's the professional masters, and people recognize that probably when you proceed in later. But I mean, that said, I don't think it's frowned upon because as people go into graduate school, things change. You recognize it wasn't the right decision, and sticking it through a PhD program just because you're deciding so it won't work. Yeah.
And there are both aspects of the work are rewarding, but they're rewarding on very different time scales. Teaching is immediately rewarding, except when you're grading, because then you realize your shortcomings. You walk into the classroom and you see this look in someone's eyes, and you're like, they understand something now that they didn't 10 seconds ago, and I had some, it was mostly them, but I had some small part in facilitating that. And that's very rewarding, and it happens instantaneously. Working on a paper, you might have a very, very big reward, but it comes at the end of 3 months. Or, there's some rewards along the way, but you're not getting you don't prove a theorem every time you walk into your office and have an hour. Well, Terry Tao does, but most of us don't. And so it's more of being a distance runner rather than a sprinter, and it's entirely. It takes some time to decide which you like. That's okay.
I think you can also go for a PhD in math pedagogy. I mean, you obviously have to look for programs who offer that and who have a strength. So there's no contradiction.
Yeah, math ed is another possibility. Right, here it lives in the Department of Curriculum and Instruction in the College of Education. Sometimes they're called STEM ed, science, technology, engineering, and math. And we desperately need it. My wife and I took a weekend, something quite random, took a weekend trip to McDonald Observatory this summer to see the star party. And I saw the fantastic job they did getting middle school and high school kids, young adults, excited about astronomy. And it really reinforced to me how important it is to a society to have people working in all levels of education, so that they can have the background to come to a place like this, and then the background to come to a graduate program like this. So, I want to therefore amend my previous comment about community college. With a master's, you can teach at a number of levels and do vitally important and often very rewarding work.
Any other questions?
When's the pizza?
Just take our panel.